All right. Welcome to the stream, everybody. Um, yeah. Sorry about the restart this morning. For whatever reason, when I started this stream this morning, it didn't start my YouTube stream. I don't know why. Let me check on it and just make sure. Yeah. We're looking good here. Ola's from there. Michael's there. Looking good. Let me just check on my Twitch stream. Just want to I'm a little bit paranoid this morning because everything was a little bit strange, but it looks like we're going okay. um so yeah, we're in a good place. The other thing is this morning I was well, I got distracted trying to fix all the streaming stuff. um but then I had a weird update, a weird issue with the NX up migration, but we just removed that and everything works. So I think it was telling them it was telling me that my NX workspace wasn't up to date, um, which was a weird error. But I don't think that was the actual issue. I think the actual issue came down to um, it was looking for a file that I didn't have. I didn't have some alias files, and that was causing the issue. Hey, Abradores, welcome to the stream, man. Good to see you. Um, and glad to get messages that you're motivated. I don't want to share more than that, but I'm glad you came out of it motivated. um, so um, I don't want to share too many more details of your personal life, man, but I was happy to hear, um, I was happy to hear the messages that you shared with me at the end there. So thank you for that. um, and it's a good weekend this weekend. Been having um, I don't know. My youngest and I we play games every once in a while. Um, and a while ago we were big into this Vampire Survivors game. Um, and there's it's like Planet Greed or Greed Planet. I can't remember the exact name of it. Um, but it's a lot of fun. So I'm dragged into a call and people are screaming at me because I misaligned a typography. Oh man. Tomorrow I have an interview. I need to leave this client pretty burned out. Dude, yeah. A misaligned. That one's. I. I'm sorry, man. That's where we'll leave it, right? Um, that sounds like it sucks. Um, like let's let's be honest, right? Um, as web developers, most of the time our software is really, I mean, and this is gonna sound reductive and stupid, um, but most of the time our software is there um, to make things look pretty, right? What we're often accused of. I doubt your misaligned typography lost the company any money. I seriously doubt that. I doubt your misaligned typography cost any lives. So if we're yelling and screaming over misaligned typography, I'm very happy that you have an interview. If only well, that's the reality of a lot of enterprise level development, right? If the worst thing you screwed up is you didn't center something properly or something like that, your software is going pretty well. Um, and that's a pretty pessimistic way to look at it, right? But man, nobody deserves to get yelled at over some text being a few pixels off, right? It's just stupid. Um, I feel very proud of myself because some people wrote some bad software. I took it over, and some people were even complimenting because I made it work. And that's the thing, right? That's you can do stuff. Um, and the reason that they yell and scream is you probably have a whole bunch of coworkers that the only way they react is to yelling and screaming, which is a horrible place to be in. Um, and I'm sorry. I a lot of times I laugh in situations like this because what else can you do, right? Um, but hopefully you find something soon. This job market is tough, but I'll admit, if you took over broken software and made it work, you're already better than most of your competition out there. Um, and that that's kind of the reality of where software development is if you can write software that works, you're ahead. If you can write software without your AI, you're ahead. If you can, right, if you can analyze software developed by your AI, you're ahead, right? There's um, and I'm not trying to bag on AI at all here. What I am trying to say is that um, as as engineers, we have to start doing more engineering and less of the craftsmanship stuff, right? Um, it used to be you could take pride in the way your code was written and things like that, but it doesn't matter anymore. There's a lot of tooling out there that'll understand your code and tell people what it does. There's a lot of code like tooling out there that does a lot of other stuff, right? Um, and so um, we have to differentiate ourselves as engineers in different ways. Um, that's just kind of the reality. And burnout is a very real thing, and I've experienced some burnout recently. It, you got to be, you got to take care of yourself, right? And you got to be loyal to yourself. Like companies aren't going to be loyal to you, um, and you've got to make sure you're watching out for yourself. Make sure you're taking care of yourself mentally and things like that. It's in your best interest. Um, and the level of average software developer front end and back end is garbage from what I've seen. By the way, people are just frozen at problems, and if you can't take their hand and move this thing forward, nobody will do it. Whether we blocked until tomorrow. Um, and that there is some reality to what you're saying, and it is a little bit sad. Um, but there's reasons for what you're saying too, right? Um, and it really comes down to where people's priorities are and what where their values are. Um, for a lot of people, their values really are something other than their job, right? They go to work and their job is there for them to make money, and it is what it is. Um, and so going above and beyond is often not what they want to do, right? They just want to come in, get their work done, and go home. I mean, that's perfectly fine. We need tons of people like that come in, get their work done, and go home. But it can get frustrating for people who want to dig into the why, who want to um, it's just it's the reality of humanity, right? Hey, Minu, welcome to the stream. I would fire them, but I'm a bad guy. uh, yeah, I, I know what you're saying, and um, you know, part of part of moving up into leadership is understanding people and motivations and things like that, and um, you know, getting that fire that tends to come when you see things that you don't understand, being able to tame that. So yeah, it always depends. You are 100% correct. It always depends, Minu. Always, always, always depends. Um, anyway, we just got everything upgraded. Um, so let's see if we can even serve our tour of heroes and see if it works. I think we've got a broken store, if I remember properly from last time, because we don't have the ability to update people in the store. Because we moved to an immutable store. Yeah. Yep, our hero store is just broken, which is fine. Um, right. If we go back to where we ended last time, and let's see. Oh, I don't have WebStorm open. Let's fix that. But if we go back to where we were last time, right? We originally made a change, and then that change just so happened to work because um, we were relying on side effects, right? If we had allowed that change to stay in place, the side effects would have been the reason that it worked. And we want our software to be predictable, and so side effects are always going to make our software less predictable. So we're in this place where if we take a look at our hero store, uh, we don't have a way to update the hero name, right? So we get a hero name, and we get a hero and a name, and we need we need to update their name. So here we need to handle this update hero name, and the update hero name needs to return our heroes with the updated hero in it. What code editor are you using? I switched to Cursor. It has all configs from my VS Code and it's easier to ask questions with context than from Claude. That's cool. Very cool. Anyway, we need to fix this, right? So we need to update our update hero name. Our update hero name is going to, instead of returning this, it needs to return heroes. And then, so it needs to return heroes. And this needs to be a hero array, I believe. Right? If we look at our state, heroes is a hero array or undefined. So we're going to return a hero array. Already we're broken. One thing we need to do is we got to change it from just being a hero name. Now we need the actual hero that we're updating. And we also want the heroes array that we're updating, and we're going to update that hero array. So we're going to return a function that takes in state. Here, we're from the draft. We need to do a couple of things. The first thing we can do is we can update our hero. So we can create the const updated hero equals actually we need to make a couple of checks before we do this. So before we do this, first thing we want to do is we're just going to say if we don't get a hero name, then we're just going to return our heroes, because we don't want to update something if we don't get a hero name. And why doesn't it like this? Oh. Yep. So there we go. Why doesn't it like this? And heroes does not exist. I interpret that as an object. Heroes. Heroes. Oh, I have to return a function. So these checks have to go in here. This has to be a factory function. Okay, so it doesn't like it because we need to return this also. There we go. So that fixes up that issue. I have return type array. Yeah. Well, I've got a partial state updater, which means that it has to be a factory function. It takes in a state that has heroes on it, and it can update those heroes, right? And so that's what we're doing there. The other check we want to do, so if we don't have a hero name, or we don't have a hero, we're just going to return the heroes. The next thing we want to do is we want to check and it actually, we don't need the entire hero here. That's just a waste of memory, actually. We can just pass in the hero ID, which is a string. And we'll fix that up above. But here we can say or not hero ID. And then the last thing we can do is we can say const current hero equals heroes. And we want to find the hero. And so we can say we're looking for the hero where hero.id equals hero ID. Right. And I think hero ID is a number, so we'll fix that. And that fixes that issue. So now we've got our current hero. And so actually, we don't even want that. We want the index of the hero, because we're going to take advantage of the index of the hero to make changes using we're using mutative to do this, right? And we can see that this returns a number. So if no elements satisfy the testing, -1 is returned. So we can say if current hero equals -1, then we didn't find it in the array. We're also just going to return the heroes array. So at this point, now we can say, hey, because we've got mutative, we can write our code this way, which is nice, and it's going to be faster because mutative uses proxies to build this up, and it's going to give us an immutable object back. So we're taking advantage of the fact that we're using mutative to be able to write code that looks like it relies on side effects, but doesn't really. And it makes it easier to write code that's easy to understand. Like, this is the way most people would write this code. Without mutative, what you would have to do is you would there's a couple of ways to do it. You could create a new array where you filter out the current hero and then you append your modified hero to the end. There are a couple of ways to do it. But with mutative, we can write code that looks very imperative. And let's be honest, this is imperative code. But mutative behind the scenes is making it so our imperative code is fine. So typically, I wouldn't recommend that we do this, but mutative makes it safe for us, right? So now what we can do is we can take, hey, heroes, and we want our heroes is going to be update hero name. And actually, we don't even need the heroes here because the update hero name is going to return. We can just do this because we're using a partial state updater. What is this saying? Heroes is not assignable to type writable state source object. Do I need to add the state here? Yeah, I do. Okay. So patch state, the first method is the writable state source, which gives us what we need. And then we could pass in the updaters that are either partial objects or partial state updaters. So that should work for us. Our hero detail components. Now we have to pass in the hero. But you know what? We don't even need to pass the hero. We can, instead of passing in the hero, we could pass in the hero ID and make that a number. And make that the hero ID. And so now we can update our component here. So it passes in hero.id. And then down here, we can also get the hero ID and make that a number, and pass that in. Our value, oh, we've got them backwards. So we make it hero ID, comma value. Is not assignable to type string. There we go. That should, yeah. So now we've got our hero ID. Now we've got our immutable updater, and this is the important piece right here. We're using mutative, and what mutative does is it allows us to make proxy objects that we can then make changes against, and then mutative will give us back an object. So it's going to give us a new object. We could even freeze that object, but because we're using the with immutable state, we don't need to freeze the object, right? We made this change last week when we had side effects making changes that we didn't want. The other thing we did is we're now binding the value to the hero name, and we're now binding the input event to update hero name. We may change this to be, we can change this to be like the key up event. And let's just, well, one little trick I like to do is I just like to console.log the value that we get back. The other thing we can do is we can console .log the event. And these two things will allow us to see in the console, we'll be able to see just what we're getting in case things change. Are you using Vim bindings? You look like me when you're. No, I'm not using Vim bindings. I'm not that cool, to be honest. Well, it looks like at least our application serves. We have no errors. We're hydrating 3 components. So if we select windstorm here and we make this Obradores, our stuff is working, right? And because we're using a key up binding, it's changing on every key up. Dr. Nice is obviously me, because I can't even spell my name right? We got Ole, you know, we got Michael here. Oh, we also need Niu, right? And we'll get Michael in here, right? So we can see that everything is bound properly. And this is the importance of why I like NGRX signal store, right? Because we have our component here, right? And we take this input, and then we've got our store, and our input updates the store, but then our store also updates our our component. And we can follow this flow, and we can check the bindings. If our binding here, like if this wasn't working, we would know to check the template bindings here. Right? If this update doesn't work, then we know to check the array bindings here. But because everything's updating the way we expect it to, we know that our store is updating. We know that we know that our code is updating properly, and we can also if something was broken, we could go back to the flashlight analogy, right? So like if the display is broken, then we know to probably check the bulb, right? If we're calling our bulb our display. But if something is broken, we can check our store, right? Which we've been calling our batteries in the flashlight example, right? We can test individual pieces because we know that the library as a whole is in a better state, because we're using known libraries, we're using known stuff, and we know where we are. What is this? Switch to multi-line editor mode. Ah, cool. I don't know what it does. Fascinating. The other thing is, we've got the Angular dev tools, and so we can see our properties in here, but we can also take a look at like our Tour of Heroes component. We can see that it's got a signal store in it. That's it's being injected by the Heroes component. And we can also see that here's our hero store, and we can read stuff off of the hero store. We can also see, we've got our details component here that has a hero store in it also. And so we can see, where things are coming from. We can see, our app component's not injecting anything. The only thing that's injecting anything is the hero store. We can also profile our code. That's fascinating to me. If I profile this, rerun it. Oh, let's profile our code. Let's turn on our profiler. And let's just test and test 2. And let's go back to our profiler here. We can stop recording. And we could see the entire time that oh, that's cool. So we can see here our hero detail component is what's taking up our time. It took a millisecond for the change to happen. Same here, same here. So again, our heroes component here, and our hero detail component. This is kind of cool that we can see what's causing our change detection cycles. I actually like this. I haven't played with this too much. And then the classical injector tree, right? So we can hide our framework injectors if we want, but we can move around and we can see this is the environment hierarchy. And this is something that we talk about a lot. If you update the signal to 20.1, you can see the signals in the dev tools. I'm on 20.1. The problem is that we're using Firefox, and I don't think the signals works in DevTools in Firefox. I think we have to be on Chrome for that. Let me bring a Chrome tab over. Um, so here we are in Chrome. And let's bring up our dev tools. We will dock these to the bottom. And grab our Angular dev tools. We can close our this. So again, we can see we've got our hero details. It's injecting the heroes component. We've got our properties here. We can also show the hydration overlays. So we can see which parts are going to be hydrated based on, well, we can see that these parts are hydrated, right? And that's one of the things that we're going to take a look at, is we're going to take a look at some partial hydration and only update on interaction and stuff like that. It's okay if you look like a normie. I am a bit of a normie here. Oh yeah, Firefox for some reason is a bit behind. Yeah, I noticed when I made an example stack list at one point a few weeks ago, the Firefox, yeah. Gotta click the gear. So you're saying dark mode. We can enable, and we can enable the signal graph. Let's take a look over here also. Oh, nope, we've got this one. So we've got everything here. Let's one thing that I always like to do is taking a look at our metrics, right? Our LCP is really low. If we look, the LCP I think is supposed to be below 0.2. I think we have no CLS. In our interaction to next point paint, this is supposed to be below 200 milliseconds. So our numbers are looking really good. And we could take a look at, it took 8 milliseconds when I clicked for something to happen. And it took 16 milliseconds for the entire body to update. We could look at any layout shifts, but we don't have any layout shifts. Actually, I think LCP is supposed to be below 2 seconds, right? Oh, we're bright here, and I don't have the tools to turn it off. 2.5 seconds. So we're well below what our LCP should be. So we just turned on a whole bunch of stuff. So we can see our hydration stuff here, that we're all hydrated. And we've got our hydration overlays going on right now. So we can turn on our hydration overlays, but Angular's letting us know, hey, these have been hydrated from the server. We'll mess with partial hydration later, but we can also see like our signal graph. And so if we take a look at our tour of heroes, we can see these are on pushed, but we've got this unnamed signal source that's going to an array that's going into our tour of heroes, right? If we look at our details, we've got a signal here. So this is our heroes array. And that has a computed in it that is giving us a 12. And then we've got another unnamed array that's giving us our heroes, right? Which is being combined into another array that gives us the ID and the name. And that's coming from our component, right? And that's flowing into our component. So we can see that we've got our store, which is here. And we've got a selected hero ID of 12. This is going into, so our hero store, right? And we set it up this way so we know. So our hero store, we have a selected hero. Our selected hero is this hero right here. And we've got the named, unnamed array. This is coming from, so it's going through a dependency array. So if either things change here, then this computed value here is going to change, and it's going to update the template. We can see that our stuff is only listening to the things that we've bound in the template, the ID and the name, right? Same here. This one is just a much bigger, right? We're just getting a full array. And that full array has an ID and name in it. Actually, that is the entire array. We don't have anything else about the heroes yet. So we're injecting the array, or we're injecting it at this level. It's being provided at this level. We're actually reading values out of it. We're updating values, but we can follow through our entire signal chain. And this is a cool tool. And thank you for bringing this out, Michael. The fact that we can take a look at our entire chain is huge. But the Angular dev tools, and you guys should install these in your browser of choice. They're going to give you all sorts of information about like what's injected. You know, you can look at what's there. And what did I do? How did I break the signal tree? Oh, you can double click and go into stuff. That's cool. I didn't realize that. I was just trying to get my signal graph back. Profiler. And then like the router tree is another awesome piece that we don't have any routes yet. We will as we get into the lazy loading stuff and things like that. But you can look at your active route and stuff like that. The injector tree, oh, it's the show signal graph up here that shows it. So very cool. We can look into our signal graph. We can look at the state of the signal right now. Very, very helpful. But the last thing that we can go through is like this injector tree, right? And this injector tree is helpful because it shows us where we're getting our stuff from. And so whenever you go through DI, there's more work, yeah. And Michael is like deep into GitHub right now, following all this stuff up. So he's always providing me useful hints and stuff like that. But when we talk about dependency injection, it's really a hierarchy. And this is the power of Angular's DI, is we can dig into the dependency injection and see where things are being provided. So if I turn this off, but we can see, like, if we look, we can see that the heroes component and the hero detail component are providing some, are part of the element hierarchy here. So we can see that the hero detail component is grabbing stuff from the heroes component, which is grabbing it from the app component. We can see over here, this tree is also showing us where things are coming from. But if we look at the hero detail component, we can walk back up the dependency injection tree, right? So when Angular looks for something injected in the hero detail component, the first thing it's going to do is it's going to look for a provider in the hero details component, right? So if we go take a look at our code, we take a look at this hero detail component, and we could take out these console logs because everything works. But let's say we're trying to debug an injection issue, right? The first thing we can do is we can take a look at this graph here. And so if we take a look at this graph, what this graph is telling us is how Angular is going to walk our tree when we look for something. So here, we can follow the injection back. So when we ask for the hero store, the first thing we can do is we can go up here in our component decorator and we can look for providers. There's no provider here. So we know that the heroes detail component is not providing that store. So the next thing we can do is we can walk up to the heroes component, right? So if we go back here and we look at the heroes view, did I make any changes here? I hope not. But in the heroes view, we can see, hey, here's the heroes store. So the heroes store injected here is provided here. And this is a good way to learn the path that your stuff is injected, right? So we walk back up to the heroes component, and then we walk to the app component. Here we can see that these two basically match up, right? So we've got the element hierarchy that walks back to the app component. The app component is the root component of our application. This is the bootstrap component. And so that's why we're getting it here. So let's say we didn't have a provider here, it would look for a provider here. If that provider was not in this app component, then we've moved beyond that and we're moving into the root component, right? And whenever you're marking something as provided in root, what you're doing is you're saying, hey, the injector is going to be here, right? So anything you provide in root is a higher level injector than in the app component. So if you put a provider in your app component, then your root component is going to be overridden and you're going to get what you get from your app component. We don't have any route outlets, but you can see that this flows back into the main app component too. But we can walk this stuff back. So then, we get to platform providers, and this is where things can get interesting. So if we take a look at our platform providers, we've got a couple of injection tokens, right? We've got the injector scope, we've got platform destroy listeners, we've got the platform ID, the platform initializer, the document token, console platform, and stuff like that. These are providers provided by Angular. We can override these providers here in the root, right? Because we've got injection providers, we've got environment initializers. This is, we've got ng zone. Oh, no, we don't have ng zone. And we can prove that by just typing zone here. But Angular still provides ng zone. When you use a zoneless provider, what you're doing is you're providing a no-op provider to Angular for ng zone. And that's done at the root level, right? The platform level are things reserved by Angular. The root level is us, right? You've got your environment initializers, and you guys are probably hooked into this if you want to do things when you set up things up. And we've got the injection token for running changes outside of the zone. We've got the error handler, right? When you set up a global error handler, that injection token set up here. You can mess with your change detection schedulers, and that's done a lot by like the test bed and things like that. You've got, your global error handler. There's just a bunch of stuff set up in root, plus anything else you set up in there as being provided in root. And then if we look at our standalone component, really we've only injected the router module, the common module, and stuff like that. And then we get into the actual app component itself. So this is the bootstrapping piece. This is the actual component itself. No, it's not bootstrapping because we are providing routers and ng module ref and stuff like that, right? But this, once you get to this side, now you can go look in the code for providers. And this is a helpful way to be like, hey, I'm here in the heroes detail component. Where is my stuff coming from, right? And we can hide the framework injectors. And once we hide the framework injectors, we can really see the platform. We've got a couple of things. Root, we've got a couple of things, right? And then our standalone, we've got a couple of things. Oh, now we finally get that. Once I hide framework injectors. Why wasn't I getting this before? Oh, because I was going there. As soon as I go here, we can see that, hey, we're providing the signal store. And then we can also see, is this a view provider? We can even log our stuff out to the console. And here we aren't providing anything in the app component. So we can actually take a look at what we're providing. And so here with the hero details component, we can see, hey, we aren't providing that store. Oh, here's where it's being provided, right? And the last thing to mention, and this is an important piece. If I close all this stuff, I guess I can go here. The last thing to mention is, this is the bootstrap. This is a root component. And it's providing some stuff in the bootstrapping. This is the root. This is anything we've provided in root. This is the platform. If Angular walks past the platform, if we ever get here, this is the famous R3 injector error that you get, right? No provider for whatever. So if we didn't provide the store in the heroes component, as we walk back, Angular is going to say, do I have it here? Nope. Do I have it here? Nope. Do I have it here? Nope. Is it here? Nope. Is it here? Nope. Is it here? Nope. Oh, null injector. Null injector, as soon as we hit null injector, whatever we asked for, null injector throws an error saying, hey, it couldn't find that, right? So by the time we've gotten that error, Angular has walked through the entire tree. This is the important part of dependency injections, and this is what injection tokens do. Injection tokens allow us to register something that Angular can look up. So when you create a new injection token, what you're really doing is you're creating the name that Angular can ask for. It's kind of like the phone number, right? Well, I guess we could call it like the name, right? Because when you ask for something, my injection token, it's kind of like you're asking Angular to walk to, this office. Hey, is my injection here? No. Is my injection token here? No. Is my injection token here? No. Okay, is my injection token here? No. 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 The injection token doesn't exist and quit asking, right? It's kind of the way it works. And that's a way to think about it. Draft PR is making zoneless 20.2. Yeah, that was huge news. So in 20.2, it's likely that zoneless will go out of developer preview and be part of Angular. And then in 21, the PR just went in that says that by default, when you create a new component in Angular, or a new application, not a component, a new application in Angular, that new application will be zoneless by default, which is huge. Bad that if to provide a component in your routes, guards, resolvers won't have instance of your component because it is not element injector. Interesting why it's built that way. So the route, if I was routing to the heroes component, then we could provide it here. And the default slash route, like we aren't providing anything. So if we look at our router tree, we don't have any components in our router. So there's no router outlet. If we were providing the heroes component on the slash route, then this arrow would point to the router outlet, right? And so then it would walk back through heroes component, then it would walk through the router, and then the app component, and then up the chain to the null. Does that answer your question, Ole? The reason that we're not here is that we're directly importing the component into the app component instead of using the router outlet. We can take a look at that in the code. So if we take a look at the heroes view, where is my router outlet? My router outlet is in the app component, I believe. Yeah. So really, we could make the tour of heroes. We could make that change right now. I haven't made that change yet because I think Tour of Heroes has us update the routing. And this is the way that Tour of Heroes had us do it. One thing that I always do, I always make my components self-closing. So the reason that we aren't in the router outlet chain is that we're directly provided in the app component. And we can even see that in the diagram, right? This diagram shows us that the heroes component is directly linked into the app component. As soon as we add routes, then the heroes component will link straight into the router. And the reason it does this is that we could potentially have like a header and things like that, and then have a router also. So there's stuff that we would need to look at. One thing to be aware of is that if you add a provider into the router outlet, it works very similar to root in that when they navigate away from that route, that provider is not cleaned up. And so if you're relying on navigation or component destruction to clean up, clean up memory or whatever based on your provider, you should provide it at the component level and not at the router level. The router level never gets cleaned up, very similar to the root level. The root level is never cleaned up either. So these wind up being kind of global, both the root and the router outlet. Yeah, and that is the tricky part, right? And so you have to be very, very careful about where you provide things. But you know, I think I was going to give um, my talk tomorrow on um, on Conway's Law and things like that. But I really think um, I just I just figured out what my talk tomorrow is going to be about. Um, the Conway's Law thing was suggested by somebody that I work with, and I think it's a useful thing to understand. But I like this a lot. Um, Being able to talk people through the dependency injection and then injection tokens. Um, I think that'll be a useful talk tomorrow. So you guys just got a preview of my talk tomorrow at the in-person Angular community meetup, which is part of the Salt Lake City GDG Google Developer Group. So I'm looking forward to that talk tomorrow. Just so you guys know, I really haven't prepared yet, but I think this will be very, very helpful for people. I may even just walk through exactly what we're showing here and how to debug that. Maybe we'll even just do something on the Angular dev tools. That might be a good way to go about it. I think I'll do that. So you guys basically got a dry run of my talk tomorrow. It's tomorrow at 6 p.m. Mountain Time in Salt Lake City. If you're in the Salt Lake City area and you want to join us, it's at the Salt Lake City Public Library in downtown Salt Lake on 4th South. So we'll all be meeting in person there. And if you guys can't make it in person, like I don't know how many people are in the Salt Lake City area, but if you can't make it in person, it will be broadcast online, and I imagine it'll be up on YouTube, just like any Angular community meetup stuff. Absolutely, Michael. I'm looking forward to being derailed by people in the chat. I really look forward to that. So if you want to join and derail me with bad puns or nerd snipe me for whatever reason, I'm happy to do it. I tend to be more focused when I'm doing presentations because I've got like 20 minutes. And I need to make sure that everything happens properly in those 20 minutes and that I'm providing good value to people. On my stream, I recognize you guys are just masters of getting me off topic. And I love that about my community. I love that there's just that give and take. But the other thing is, I recognize that the questions you're asking are stuff that's important to you and stuff that you're probably encountering in your day to day. And so it's in my best interest to get distracted, so to speak, and to answer those questions. So yeah. But yeah, I think I've been kicking around the idea of dependency injection and injection tokens. And I think what we'll do, that was kind of my previous idea. I really wasn't feeling the talk that I started writing on Conway's Law. I think it's important to understand. Do you guys know what Conway's Law is? Just out of curiosity. Like, if you guys, I'm sure you guys have experienced Conway's Law. Are you guys familiar with Conway's Law? Conway's Law software. Ooh. Let's fix this. There we go. Conway's Law is like when Family Guy cuts away to Conway Twitty for 5 minutes. Close, very close. Conway's Law is one of my absolute favorite laws because this is held up everywhere I've ever been. And it comes from the book How Do Committees Invent, and it's attributed to Melvin E. Conway. That's how you know you were born in like the 50s or 60s, is when your first name is Melvin. That's not a very common name in the U.S. anymore. In fact, in the 90s, the name Melvin in the 90s, in the area where I was in the U.S. for a while, was like slang for a nerd, right? Which everybody hated nerds in the 90s, and now everybody loves nerds and geeks. It's a weird time to be alive. But anyway, Conway's Law basically says organizations which design systems, in the broad sense used here, are constrained to produce designs which are copies of the communication structure of these organizations. What does this mean in English? What this means is that any system that any sufficiently large organization produces, that system is going to mirror the way that that organization communicates. How does this apply to software? Well, let's say you've got team 1, right? And they're siloed away in their stuff, right? And you've got team 2, right? And they're siloed away in their stuff, right? And then you've got team 3, who's siloed away building their stuff, right? Team 1 is very prickly. They hate everything. And everything that goes to team 1 has to be very, very formal, right? Team 2 is kind of the middle person, and they like to smooth over conflict. And so, people tend to go to team 2 when they want to deal with team 1 because team 2 has this relationship with team 1 that allows them to communicate easier with team 1 and blah, 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 right? Team 3 and team 4 and team 5 are, a bunch of other engineering teams. They're just out there doing their stuff. They don't care about anything else. They're just out there throwing up houses and stuff, right? How does this translate into software? Well, typically, the software design would mirror this. We would have a module that's team 1's module, right? And team 1's module will communicate with team 2 directly. And team 2's module will communicate with team 1's module directly. And these two work pretty well together, right? Team 3's module over here communicates really well with team 2, and team 2 communicates really well with them, right? Because they're kind of the glue that holds the organization together. But when team 3 wants to communicate with team 1, there's this special module that team 3 has to go through, right? And then there's another special module that they have to deal with. And finally, they can get to team 1, right? And team 1 enjoys adding these special modules along the way because they want everything to be very, very particular, and right. So this chain can get very, very complicated and stuff. And really what happens is team 3 is just given up on this. This is the legacy path. Team 3 has learned that really, if you want to communicate with team 1, you go through team 2's module and everything's better, right? That's Conway's law kind of in a nutshell. And right, if team 1 wants to communicate with team 2, they just go straight to team 2 and they're like, hey, you do this, right? But team 2, to be able to communicate at all with team 1, has to go through this big massive chain. Everybody hates it, right? And it's all flaky software all down the line, but it's all stuff mandated by team 1 because team 1 is just very, very prickly, and they hate everybody. I don't know, I'm making stuff up, right? But maybe I'm not. Maybe I've seen this at too many organizations and understand how this is, right? And maybe you guys are going, oh, wait, this is my organization. Or, oh, wait, this was the organization that I worked at before I got out of there. Or, oh, wait, yeah, I remember this from a couple years ago at that job that I was, right? Like, or, oh, man, I worked in open source and holy crap, you're right. This is how it translates into software. The problem is that the more prickly team 1 is, the more prone your software is to have problems. And the thing about software engineers is we're kind of like water, in that we find the easiest path to something, right? If this path is long and winding and complicated, eventually we're just going to follow the easiest path, and our software is going to mirror that. For anybody to talk to team 1, they have to talk to team 2. Team 2 starts to get overloaded because everybody's coming to team 2 because team 1 sucks so much to work with, right? Yeah, teams are wonderful. Eventually you'll work in a team that's big enough that or an organization that's big enough that you'll have this kind of stuff. And I've got a bunch of different theories about big organizations. I've got my whole fiefdom theory that has held up to testing so far, in that as soon as you give anybody a little bit of power in an organization, they're going to set up their fiefdom in that organization, and they're going to bring in knights and stuff like that to protect that fiefdom. It's kind of a pessimistic way of looking at organizations. But as soon as you set up somebody to do something in an organization, they're going to start connecting and bringing in people to help protect their power and that peace. And as soon as somebody recognizes that, oh no, there's an external threat to my little piece of the fiefdom, they don't look and they're like, is this good for the organization as a whole, right? It kind of becomes the French Revolution, where we're going to hold on to power no matter what. We don't care what's better for everybody else, right? Let them eat cake, whatever. And eventually you wind up beheading a whole bunch of people to claim their fiefdoms, and make moves that are good for the organization. It winds up being horrible and ugly. But that's just the thing, right? As people, when we get power, we kind of feel like that makes us a little bit important. And we feel like if we lose that power, that our importance goes away. That's not always the case. That can be the case in a lot of places, but I don't know. Lots of organizational stuff kicking around in my head. Maybe one day I'll write a book. Who knows? But that's your sideways rant on. That's your off-topic rant on organizational structure and how your software looks like your organization that you're at, right? And right, if you're a team of 1, your software always looks amazing because it's the software that you built, and so you understand it. And so that's another important piece to recognize, right? That oftentimes a team of 1 may not be building as good a software as you think it is because it's not getting all the external pressures that a lot of other software will get. Have a good one, everyone. Hey, Michael, nice to see you. Only one team of us, not one person. Yeah. We'll see you later, Michael. Thanks for joining today. It was good to see you again. And as always, thank you for the stuff you send me. I know it takes a while sometimes for me to get back. My attention is divided so many different ways right now. But I always appreciate the stuff you share, Michael. So thank you. Anyway, back to the software, right? Back to what we're working on. So right now, our Angular tour of heroes is looking okay. It definitely needs like a designer to pass through it. And this is where my wife is a huge help. Because what I think is good UI and what everybody else thinks is good UI are often two different things. And I recognize that about me. It's not something that is easy to change. So typically, if I want to design something publicly, if I'm not designing it with people, typically I'll design something. I'll take it to my wife. She laughs. She spends a couple of hours in Photoshop or InDesign or something, taking my design and turning it into something that looks good. I take that, make my software look better, and we're happy, right? And that's the importance of like designers and stuff. I can make the pixels look however I want them to look. However, how I usually want them to look is not the way they should look. So I do recognize that weakness in myself, but yeah, it needs some help. It's functional. It doesn't overflow. We don't have a whole bunch of elements jumping around, which are big deals to me. But it also isn't. Nobody's going to be like, oh, you should go design things to look like Jason's Angular tour of heroes. That's amazing. So, a little bit of self-deprecation never hurts, right? Actually, that's one of the things that I learned a while ago. If you want to be a more powerful speaker, taking jabs at yourself often helps the audience feel more. It helps the audience feel more. What do we want to say? More at ease. And once you get your audience to feel at ease, they're going to start listening to what you have to say, and stop judging a lot of the other things about your presentation. So, there's an art to it. You don't want to tear yourself down and make the audience uncomfortable. But if you can take little jabs at yourself here and there, the audience is going to be like, oh yeah, I was thinking that too. That guy, his designs suck. Right. And suddenly now we're seeing eye to eye. And now I'm not here like, oh, I am God's gift to programming in Angular. I'm the best web designer ever. No, I don't think that. Right. But that is kind of the air that often comes across when you're speaking or creating content. And it's not intentional. I don't think anybody that I've met, as I've had the opportunity to meet a lot of the amazing content creators out there, and a lot of the thought leaders that are out there. There's not a single one of them that I would point to and be like, oh, that person's untouchable. They have a lot of the same insecurities as you and I. They're just really, really good at explaining things, and they're really, really good at building things for the community. And so people tend to put them up on these pedestals. If you want to get into like content creation and speaking, learning to slow down your speaking, learning to take jabs at yourself, learning to roll with the jabs you're going to take are some skills that will help you out quite a bit. Anyway, I think what we need to do is commit. We'll go ahead and stage all of this, and we're just going to say that, hey, we added the heroes detail component. Boom, and we'll commit this. and we'll push it because we finally got some working stuff. It's not broken. Maybe we'll end today's stream without something broken. We still got about 40 minutes before we need to end. So let's go take a look and see what's up next. I mean, in the Angular tour of heroes, what we just spent all that time talking about is really a couple of paragraphs. But the difference is we chose to do it in a way that is going to be more friendly in the future for extension and changes, and it's more testable. And that, like, one, the Angular tour of heroes was, I believe these are the Angular 17 docs. So these are three versions out of date, right? So there's some stuff in here that we wouldn't do anymore, like the ngIf and things like that, right? But it still stands that if we put this if in the component, we have to test the component. And that's going to be a big piece about looking through this. But one of the things, as we talk about like AI and things like that, AI is going to generate code like this. And that means when AI, well, and the reason AI is going to generate code like this is that the vast majority of code that's written in Angular looks like this. Anywhere you go, any organization you go to, it doesn't matter the size or how advanced they are, anything like that. I guarantee you, at any organization you go to, there are people producing code that looks like this, and there is, there's code in the code base that looks like this. What's wrong with this code? Well, if we look, we want to look at things like what's going on with this template. Well, this is logic in the template, right? That means that we have to test something here. But this isn't one test, this is two tests. There's one test where if it's true, there's a second test where if it's false. So we have to test that it exists and it doesn't exist based on selected hero. And a lot of people will be like, well, you're testing the framework at that point, but you're not really testing the framework, because if this logic is not tested and it gets broken, then you don't have tests that catch that broken logic, right? This could turn into 3 testing paths, right? Because you might want to test the null, or it could become 4 testing paths, because you might want to test the null, you might want to test the undefined, you might want to test the falsy, and you probably want to test, well, you definitely want to test the golden path, right, which is when this is set. So we've got between 2 and 4 tests already on just this one line, right? Because of a decision we made to put some logic in the component. We've got another test here, right? Where we need to make sure that the hero name is in all uppercase. So there's one more test here where we have to test that. This is just binding. We could or could not test this. It's possible, but there's another test there, right? And then, there's a potential test here. So this comes in at between 2 and 7 tests for a simple little piece of code because of the way we chose to do things, right? I probably wouldn't test this ng model binding. I would say this is testing the framework. I probably wouldn't test this. I would say this is testing the framework. I would test this, and I would do all 4 of these tests. So for me, this code is 5 tests, right? Which is a lot. Some things we could do to make this easier. We could move some of this stuff into component, like into services and things like that, and reduce the number of tests, right? But this is just the kind of stuff that as you're analyzing the choices that you're making, as you're working through your code, we want to make sure that we're looking at the code and the choices that we're making. We aren't necessarily looking at reducing the number of tests, but any test that's done on a component is going to be 3 to 4 times slower than any test that's done on a service. And the reason for that is that when you spin up a service, you don't have to spin up the virtual DOM, you don't have to spin up all this other stuff that comes along, right? Any test that we can move out of a component, right? Even if we move this stuff to services, I would still be testing those services. So the number of tests wouldn't change. What would change is the speed of my tests. And it may not be a linear change, because we may not have to instantiate the service over and over again. When we're doing DOM-based tests, we've got to clean up the DOM, reinstantiate the DOM, set everything up, and then we can run our tests. And that's why E2E tests and component tests are so much slower, and why they're towards the top of the testing pyramid, right? They're more brittle, but they're also slower. They take more time. We want more unit tests, and we want more automated, more tests that run faster and that are repeatable and less brittle. So that's what I'm talking about. I'm not trying to reduce the number of tests. What I am trying to do is reduce the amount of time that we spend in a CI/CD pipeline waiting for tests. And anybody who's worked on a large enough project has probably been involved with test splitting, because maybe your CI/CD pipeline has like an original 20-minute timeout on a task. Then you extend it to 30 and then an hour, and then your CI/CD pipeline, the max time that it ever allows a task to run is for an hour. So then you're splitting tests so that you have tests that run in under an hour, and it just gets to be a mess, right? If we can make our tests run faster on the order of milliseconds instead of seconds, then we're helping that situation along. The other thing is, the longer it takes to run tests, the less likely that an engineer or a dev is to run your tests. So that's why we're doing things the way we are. So we styled the selected hero. We've got our code review. So it wants us to create a feature component. So at this point, the heroes component displays both the list of heroes and the selected heroes details. Does our heroes component do that, or did we do something different? We've got a hero detail and we've got a heroes, but we could very easily make our list its own thing. Let's take a look and see what they're suggesting. The first step is to move the hero details into a separate reusable hero detail component. We did that. Okay, so we're a step ahead. So they're refactoring things, and this is something that I suggested. I get this question a lot lately, and I used to not write my code this way. I used to put my templates in their own file, but I had some good people in the community who were like, well, why are you doing that? Right. And of course, my first big thing that I threw out there was separation of concerns. Well, it's not separation of concerns, so that doesn't work. So my whole solid argument was thrown out the window. So now I had to go back, and I was like, well, it's just easier for me. Because that's the way I've always done it, and that's what I had to fall back on, right? Well, I had some very intelligent people tell me, your template is code. the bigger you allow your templates to get, the more hidden code that you're adding. And I noticed this when I went and looked at my files. I didn't look at my templates all that often. My templates just kind of lived in this file. I only went into them if I needed to add something or move something or things like that, right? But I never really looked at my templates. As soon as I started putting my templates into the same file, I started to get, and I don't know if you guys have this issue, but I have this issue where as soon as my files start to approach about 100 lines of code, I start to get this anxiety. And I'm like, man, this code's too big. I'm doing too much. And you know, sometimes on inspection, it's like, no, it's got to be that way. You know, for encapsulation or whatever other reasons, I've got good reasons for it. But every time I hit that file, I forget my reasons and I have to go investigate. And I see this as a good thing for me. And the reason I see that as a good thing is, guess what? We've got this giant template here that we could move into its own component, and we could probably just take this piece right here and move it into its own component, and that's going to make this piece of code smaller. But the other benefit is we can see this block of code, and if we want to render our heroes in a list the same way, we can reuse this code, right? We may not reuse it now, but it's useful for us to evaluate this. And this is why I put my templates in my code. I don't often put styles. Sometimes I put styles in here, but the reason I don't often put styles is that styling is not as much code, and there's not logic in my styling. There is sometimes, but not really. And this tends to push the size of this file to where I start to get, you know, that little itchy part of my brain that's like, hey, you need to refactor. If I move my styles out, I tend to not get that. Yeah, we could. You could make your card with ng content a separate component. Absolutely, right? So this card could be a separate component. I'm not going to do the card. I am going to do the list because there's no reason for me to do the card yet. But that, like, on a bigger project, having a card component with an ng content where you can insert the ng content is the right thought to have, right? I'm not going to do that because I want to keep us moving. But I like where your head is, Ole. And I would always accept PRs where somebody's like, hey, I want to reuse this card component in multiple places. And right, we're already making use of some stuff that would make it reusable by having the card height. So we could set variables like CSS properties, right? CSS variables or properties, whatever you want to call them. We could set those. And so this piece, this card is already fairly reusable. I'm just not going to do it in this case because I don't want to spend time refactoring too much, but I do think that the heroes list is worth refactoring, and it follows along with what they're sharing here. And I do like this about this, right? That we need to think about all of our stuff. So they're saying we want a heroes details component. They're going into like inputs, right? And we had this discussion. We've already had this discussion. And so maybe I should have read ahead to see that, hey, they're going to encourage us to do that. But this is good stuff to know. And we had discussions about input properties and signal inputs, model inputs, and things like that. But we decided to use the store directly, right? And we had good reasons for doing that. But this is a good discussion. So let's follow through and do the same thing with our hero list. So the first thing we want to do, we want to come into our components here. And here's an interesting thing. A lot of people will jump straight to like a shared library or things like that. And there are pros and cons to each approach, right? So, in the very beginning, we had me and you, who came in, and their first comment was, "It depends." That's very much the sign of a more senior software engineer, when they don't say you should do it this way, when they instead say it depends, right? And there are pros and cons to every approach. I tend to take this approach because in a large portion of software that I've written, pieces that I think will be reused are often never reused, and pieces that I don't think will be reused are reused quite heavily. And so my strategy is to take any new component and put it as close to where it's used. So what do I mean by that? Well, where's my mouse? There it is. What do I mean by that? Well, in this case, we've got the hero detail component and the heroes component, right? And these all sit next to each other. I would suggest that the hero list component should sit here. As soon as the hero detail component needs to be reused, that's when it gets moved into a shared library. And maybe as soon as the heroes view component needs to be reused, then it gets moved into a shared library, and then I move this entire library to a shared library, right? Why do I do this? There are a couple of reasons. The first reason is it makes it easy for me to find things, because things tend to be close to where they're used. And in more complicated projects, I may move, from one lib to a shared folder in that lib to then a shared library, right? So there might be tiers to the movement. So that's one piece. The other piece of that is that tree shaking is often messed up by people's index files. And a lot of people don't analyze their bundles and their bundle sizes and what's causing their bundles. And so, like, when I export the heroes view, this, in a lot of cases, this index.ts, everything I put in here is going to be imported. Unless I spend some time analyzing my exports and making sure that my exports don't depend on each other and things like that. And there are other things that you can do to cause problems. Like, for example, I like to add testing and stuff. If I add testing, then I can have hidden testing libraries come along for the ride in my UI bundles, because I didn't set up my my barrel files properly. TIA, like TypeScript, has addressed this a while ago. Not using barrel files and things like that. With you can do named exports and things like that. Angular doesn't support that. And once Angular supports that, then my argument will be a lot less powerful. But until Angular supports that, co-locating code allows code to live where it should be, and it becomes easier, to not mess up index files and to not have accidental imports. You're still going to need to do your bundle your bundle analysis. You should always be doing bundle analysis. And that's why on stream, we've done bundle analysis a couple of times. But just know that a lot of times by using relative imports like this, the tree shaking will go easier. And that's why I tend to do it this way right now. Along with the the mental help of things are located closer to where they need to be, and that allows things like library rebuilding to be better and things like that. So you don't like if I were to locate something that's only used in one place to a shared library, and then I make a change to that, that shared library is then used across a bunch of different applications. All of those applications might need to be rebuilt in an in an affected build if you're using NX. Whereas if I locate it close to where it needs to be used, then only the things that it affects will be marked as affected, and only those pieces will need to be rebuilt. So there's a lot of reasons why I do it, but tree shaking really is one of the big ones. I just wanted to bring that up. Anyway, we're distracted, like usual. So let's create the new new component. So our new component. So the path to our new component is going to be our heroes list component. And what I'm doing is I'm watching the dry run down here. So I'm seeing that this is going in libs UI source lib components heroes list. That's exactly where I want it to be. So we're good here. I don't need to mess around with a path at all. I'm not going to export it. Standalone by default, because Angular. Change detection, we're going to go to on push. We'll turn on display block because I always do it. We're going to remove that right away, but we'll turn it on for right now. We could do export default. I don't really do it because I don't. Even when I do lazy loading, I don't typically do a default import. So inlining the style, we've been doing that. Inlining template, we just talked about that. We don't need a module. We're going to let it generate its own symbol name. ng-html, this is an interesting change that I actually in support of. And if we weren't putting the template in the same place, then I would add the ng-html. The other nice thing about putting like the template and the styles in the file is you can see that our file list is a lot smaller and it's easier to put things together. Usually what would happen here is we would have a heroes view folder that would contain the heroes view.ts, the heroes view.spec.ts, the heroes view.css, and the heroes view.html. There'd be four files in there. And so we'd get a whole bunch of folders. With this, where there's only two, the test and whatever, it's a lot easier. We're going to leave the prefix and selector alone. Style CSS is fine. This type is what's adding the dot component here. If we removed this, we would see that we would just get the heroes list and stuff like that. I'm leaving the component in because I'm still not entirely sure where I fall. I understand why the community says what it says, but I also work in a very large organization. When you work in very, very large organizations, sometimes being overly explicit is a benefit. And so the component thing tends to resonate with me still. The last thing is like the encapsulation. You can do emulated encapsulation. You can do no encapsulation, or you can do a true shadow DOM encapsulation. If you don't pick anything, Angular picks the emulated encapsulation, and that's why when we look at stuff in our application here, say we inspect this, we get this ng content ng. This like we get these ng content things like this because Angular is using them. So let's take a look here. I don't think I have anything with an actual. I think we're just using we're using Tailwind for everything. And so because of that, we aren't really using Angular's encapsulation. But you guys have seen this before where we'll have these ng content things. Well, that not the ng content. Yeah, it will show up. But you'll have like the attribute selector followed by your classes. And that's how Angular's scoping your classes to that component or the tree below it. And that's why we need things like ngDeep and things like that, right? If you don't want to have to use ngDeep, you can set this to view encapsulation none. And I've seen that in projects before. I recommend leaving it unset and allowing Angular to do its encapsulation because it tends to emulate web components fairly well. Actually, really well. I really like the way they do their encapsulation. And in the rare cases where you need ngDeep, then you can use ngDeep. ngDeep has been marked as deprecated forever. The Angular team says it's not going anywhere until they come up with a solution for ngDeep. And in Tailwind, you often will have to add ngDeep if you want to override a Tailwind class or things like that. I don't use ngDeep as much because when I'm using like Tailwind, and because I've used Tailwind, I tend to design my CSS this way. I tend to, instead of putting my overrides at the component level, I tend to move them up to the global level, and then scope them with selectors or things like that. And the reason for that is it tends to work out cleaner than ngDeep, and it allows for the proper cascade and inheritance and things like that. And then if I want to use component only scope, then I don't use ngDeep. If I want that to override something at a higher level, then I will add, typically like a scoping class to it. So, if I want to override something to have maybe a red outline, I would do, input red, and then I would have the I would use that as the enclosing block, and then inside of there I would override the the Tailwind or whatever I want to do, and so that way I can add the input red class to my inputs, and then Tailwind will handle that appropriately, and it tends to work out better than ngDeep. But that's what the view encapsulation is for. And if you go true shadow DOM, be ready. Like, you need to understand the shadow DOM well, because piercing the shadow DOM is very, very difficult. And so just be careful about going true shadow DOM. The encapsulation works really, really well because you can override it easily. But like if you go true shadow DOM, then things like ngDeep don't even work. So be very, 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 very careful about the encapsulation. I just tend to leave it alone. Oh my. Oh, I distracted myself so much that I didn't even generate the component. Way to go. Way to go. Let's do that again. Heroes list. Show all options. Change detection. Display block. Inline. Inline. Oh, I'm going to get distracted again. In the past, I used to use SCSS. CSS has become so powerful with nesting and stuff. And I very rarely take advantage of any of the SCSS stuff, like generators and for loops and stuff like that. So I almost never use SCSS. So for me, there's no reason to add the preprocessor for it. I'm already running a preprocessor with Tailwind. So adding another preprocessor for SCSS just feels like a bit like overkill. But this time, let's actually generate. And then we'll close everything. Okay, there we go. So now we're going to say that we added the heroes list component. And the nice thing about this is it's just mostly a lift. It's the lift and shift. So we can basically grab this, and I debated the title. You know what? Let's add the title. If we ever share it, it's easy enough to make the title content. So here we're gonna go tour of heroes, and this is our heroes list. Heroes list. And so here we need the heroes list component, not the store. Heroes list component. No. We'll import that. Is that not heroes list component? Oh. Okay. Let's rename this. Heroes list component. And yes, we want to rename file. Heroes list. So it renamed everything properly. The heroes view. One thing we can do here is we can rename these tests. Do the heroes dash view. So everything stays together. I like my tests and things to be together. So now we should be able to import this. And my selector is probably misnamed. Heroes. So that is done. That should be used now. Heroes list component. Heroes list. EOH. I made the change in the template. I didn't change the selector. So now if we take a look at the heroes view, there we go. Now it's used. And now if we go to our code, the heroes list works, but we don't have a hero to select, right? So now we need to fix things again. But that's okay. That's an easy enough fix. We go into the heroes list component, and instead of this, we drop in this, and we don't have the hero store. So it's going to complain. One thing we want to do here is instead of doing this display block on the host, because we're using Tailwind, we can say that we want on the host, we want to add a class of block, and it'll use the Tailwind block. So there's a couple of things we need to fix. We need the hero store. So in the hero view, are we using the hero store at all? We're only using it there. So we can actually take all of this code here, and we can move it into here. And so now we've got our selected hero. And this is the benefit of using the component store, is we were able to take this component wholesale, copy the code across wholesale, and now all this does is react to changes in the store. This is completely reactive. And so we're in a good state, and this is the power of separating things out into the components the way we were talking about, right? Is that we can recombine them in different ways. And so the power of the tools that are refactored are so much better. We don't have to worry about so much. And when we go take a look, hey, look, right? There's Ole, right? And there is Minu, right? So we can see that our code works, and really we just did a couple of copy and pastes for this refactor. But everything still works. And the cool thing about this is, think about component testing, right? If we hadn't moved our component into a store or a service of some sort, then all of our component tests would have to change, right? Our E2E tests would have to change. There's a whole bunch of things that would have to change. Because our code is in a store, as long as that store is properly tested, we can move that code anywhere we want it to be, and it's going to work just the way it was before, right? And the last piece, if we really wanted to get tricky with this, we could make this card a reusable component. Right now, there's no reason to do that. We can look at that in the future if we want to. But we did the whole refactor in a couple of minutes. And this is the power. This is the power of what we're doing, right? We still have to have the hero store here because we're providing it at this level. And the reason we're providing it at this level is that we want the store to be cleaned up in the future when we navigate away. We want this store to be cleaned up. We don't want it to stick around and take up memory. So we are providing it at this level. But a lot of our logic and code exists in components outside of here. And these components are very, very reusable. We could drop this heroes list component anywhere, and as long as a hero store exists, it's going to work. We can drop the hero detail component anywhere, and as long as there's a hero store for it to read out of, it'll work, right? And so there's power there. There are other things that we can do in the future with like injection tokens and things like that that can make this even more powerful. But we'll leave that for the future if we need to do it. Anyway, this was actually perfect timing. Perfect time for me to end. My daughter just got home. And so these were already staged. Why were the, oh, this is the rename. Fix component name. And renaming, moving, and stuff like that, I always like to do as their own commits, just because it works better. But if we take a look at what we did, we basically just removed a whole bunch of code from this heroes view, and we pasted it in to this other view. That's all we did. So refactored to use heroes list component. And there we go. Hey, Ola, thank you so much. And thank you everybody for being here. I really appreciate it. It means a lot to me. If you guys can join us tomorrow at 6 p.m. in Salt Lake City, come hang out, have some fun. If not, hang out with us online. And if you can't do that, I'm sure there will be a replay of my talk tomorrow. I'm a big fan of the Angular community meetup. I was an organizer with them for a long time, so I have a lot of fond memories and a lot of respect for them. Very much looking forward to tomorrow. Other than that, you guys have a great rest of your day, and we'll either see you tomorrow